Let's try to understand the fallback system architecture which you can follow in your decentralized application to fetch the data from the blockchain and feed in the component without connecting their wallet. So what happened in the regular decentralized application? You can allow the user to connect the wallet, and once they connect it, then you're going to fetch the data from the blockchain, taking the signer object and feed in the component. But this is not the good approach which you have to include in a decentralized application if you really want to scale it up. You need to add a fallback system where it's going to fetch out the data from the blockchain without even connecting the wallet. So right now you can see, right now I'm not connected with the wallet, but still I can able to feed the data from the blockchain right here in my component, so I can display the investment and the current pre-sale which is going on. So right now I'm not connected, but the moment I will connect, it will have the same data. It will have the same data, and I can able to simply display right up here, which is we have here. So if I reload the page, it's going to simply load the data, and you will find the data we have exactly the same which was earlier. And it's reflecting the balance because we need the address for getting the balance of the user. But this information is very important: the percentage, the ratio, the pricing, that all data is coming from the blockchain. So now let me give you a quick walkthrough about the code structure we have designed and how this entire fallback system exactly works. So next time when you start working on the project, so you won't have any confusion. So I can come back to my context management, and this is the function we have. If I take you up right up here, you can see we have a function called fallback. So no matter whichever network you are deploying your contract, you need to build a fallback URL for it. So for example, if I show you my environment variable for the front end side, I have deployed the contract to, that's where I have deployed my contract, and that's what I have provided as a fallback URL. So by default, when the application will run, it will have the URL, and then I'm making the check right up here in the functionality. So we have this fallback URL, and I'm doing the check right up here. You can see we are taking this check. So whether if they have not connected their wallet, then we have to move to the fallback object, because there is no data available in the provider and the sign object. If there is no wallet, there is no Ethereum object in the browser. So we're going to go with this one, and here we are making the check. So you have to do one thing whenever you are doing the check of the balance. So with the fallback model, you should avoid the balance of the user. You can go with the balance of the contract, you can do that, but you should try to avoid the balance of the user. Because the moment you will try to fetch the balance of the user, you need the signer object, you need the address of the wallet, which we don't have it because the user is not connected. That's why we have built this custom logic, and we are checking based on the address. And now then we are simply executing the transaction and getting the data about the entire contract. So you should always add this block data, because sometimes there is a problem with connecting with the wallet. Sometimes the user is open the wallet and they have disconnected, so there is a problem in the wallet. You have to tackle that particular error which is happening by the wallet providers, and how you can prevent it. So this is how you can simply build a if class, or you can build a separate error handler where you can do this particular check and then you execute the transaction. So this one is very important. It's a very simple logic, but it's really powerful, and I have seen that most of the application is missing this particular feature. So simply decide where you have deploy your contract, give the particular URL, build the fallback URL, and then build the check like this. Check the signer object and provider object. If it's there, then continue with that, but if it's not there, then simply move to the fallback URL for fetching the data. Simple. Okay, so I hope you have understood that how this fallback system exactly work. If I come back to the browser, come back to the application, if I simply do the logout, you will see I will still have the data. The moment I will simply reload the page, it's still going to fetch the data behind the scene and is going to feed in my component. You can see it's feeding the data. Once it will give the data, and it will feed right up here in my component. You can see the balance, the percentage, every single thing is working fine. The ratio is also working fine. The balance is not displaying because this balance is reliable on the wallet connect, and that's what we have avoiding. If there is no address available in the function, means there is no connection with the wallet, we are simply committing up. All the address for the user is getting off. So that's how you have to build the fallback system. I hope you have understood. If you have any question, do let me know in the comment section. I'll try to help you on that. Have a wonderful day. Bye bye.